Hello and welcome everybody to the Solutions podcast and vlog. And this month I am here with Christine Nikander. Nikander, we just were talking about our names. Christine, welcome.
Thank you.
Yay. And we just met through LinkedIn. So, the wonders of social media, who I'm not a great advocate of, but LinkedIn is the one where you do tend to meet some interesting people doing some good stuff. And seeing the overlaps in our work was really quite fascinating. So really, my real fascination with Christine's work is with heavy metals, with rare earth minerals, with mining, with e-waste, with all of this stuff, which we really do need to name. So thank you for all the great work that you've been doing with the e-waste column and getting the word out there. So is there anything else you'd like to say as an introduction to yourself?
It's a good question. I think I think you already kind of hinted at it, but I think one of the big factors in my work has always been to try to connect the dots, because I think especially if we're thinking about critical raw materials and e-waste and sort of heavy metals or just critical raw materials, a lot of that work ends up happening in silos, right? So it's quite often kind of treated as if they were these different things, right? So I think kind of a lot of my work's been around trying to really track that life cycle and also just track that supply chain and put those dots together.
And the supply chain, which sadly, many people are kind of blissfully unaware of when they're, chatting on their phone, that half the periodic table is in our phone, and where did all those minerals actually come from? And that story of the environmental and the social injustice which comes from the mining of rare earth minerals. So I'm kind of my work predominantly in the Ecuadorian Amazon, I've been really aware of the mining of petroleum and of gold and copper. And seeing that legacy around, the direct impacts. And at the moment, we've got this new gold boom in Ecuador. And it's mostly illegal, and it's causing huge amounts of contamination of the rivers in the Amazon. And this is the headwaters of the Amazon. Loads of gold mining going on, which is contaminating the entire Amazon region. So where have you looked into most as far as the environmental social impacts of the mining industry?
Yeah, it's a great question. So I started doing my research into e-waste originally 10 years ago. And I think kind of quite quickly, sort of in that research, you also come across conflict minerals. So a lot of my research, I have to say, not on the ground, but maybe on a higher level, looking specifically at kind of what can regulations and laws do, has been looking at conflict minerals from the Congo. And just generally, I think kind of one of these bigger questions we've had over the last few years as we talk about conflict minerals, but normally that only entails kind of the 3TG, so gold, tantalum, sorry, am I going to get this right? It basically focuses around these kind of four elements, the 3TG elements. And I think there's been this kind of bigger question of the last few years, like, is it enough to just focus on those four components, or should we also be looking at other elements? And I think also another question has been, and something that I've kind of done a lot of work about, is kind of thinking about, well, if we're thinking about the energy transition and kind of transition mining and kind of the pressure that maybe puts on kind of virgin mining, should we maybe also be thinking about kind of other minerals or other mining that can also affect or kind of put pressure on local communities or indigenous communities and also the environment there. So I think my work's been a bit broader, but I think kind of a lot of it's been around kind of originally conflict minerals, and then thinking about like, how do we maybe need to like broaden the scope of what we're considering as a conflict mineral, but also, should we maybe start talking about kind of human rights and kind of labor issues within transition mining more generally?
Yeah, which is exactly what I was listening to Martin Smith, a professor at Brighton University, speaking exactly on this point of, we can't really talk about a green transition as if it's something ecological without really naming that for every wind turbine it needs a magnet in it, for all of, whether it's electric cars or solar or wind or any of this which is so desperately needed for the transition, where are we going to get all these minerals from? And sadly, at the moment, we're still not really able to recycle most of them. And that was what was shocking. He was saying about that in our phones, it's got half the periodic table, but 2/3 are still not really being recycled. So I don't know if you could speak a little bit more on that, as far as, we're mining it, but then how much can we actually recycle and reclaim and keep in a circular economy?
Yeah. Yeah. No, it's a great question. I think one of the really big issues that we still have, and maybe it's to a certain degree the overarching issue, is that I think kind of what happens a lot is that it's still cheaper, for some ironic reason, still cheaper most of the time to do virgin mining than to recycle metals and minerals from e-waste, right? So it's really kind of, it's a market issue that we have. Like, the market will go for the option that's cheaper. I think one of the things that's really interesting on the market right now, because of kind of geopolitics shifting around and there may be being import and export bans on certain minerals and metals, that you might actually see that, certain kind of recycling for certain metals within e-waste might actually be kind of increasing, not because, necessarily the market price for recycling has gone down, but just because there isn't access to those virgin metals or minerals because they just can't be purchased on the market because of the geopolitics, right? So I think that's a really big issue, that issue of kind of, well, if it's cheaper to do virgin mining and you can still get those minerals for really cheap on the market, why would you recycle? And I think another really big issue kind of within e-waste is always this question of or within metal recycling in general, is how do we make sure that you actually get the products, the waste products back so that you can recycle them, right? And so I think that's always been a really big issue, that, like, especially for thinking about consumer electronics, small consumer electronics, do consumers even know what they should be doing with these electronics? Do they even recognize that they are electronics? And then maybe to go a step further, to even give, consumers a little bit the benefit of the doubt, if you go and bring your e-waste, let's say your broken phone, to a recycling center to be recycled, like, there's no guarantee that the whole thing will really be recycled, right? Quite often what happens is that the most valuable aspects are the ones that are kind of cheapest or most effective to get out. They're going to be taken out, right? But if we're thinking about kind of, I don't know, things that maybe don't have such a big market value or maybe aren't that easy to recycle, they might just really end up as waste, right? So I think the market plays a really big role in this, in terms of kind of just like the pricing of things. I think kind of getting the waste to the place where it needs to go to be properly recycled is a really big issue as well. But I think then there's also just issues around kind of, let's call it leakage, right? That you don't actually necessarily know that all the e-waste or all the kind of scrap metal or scrap minerals are actually going to be recycled, because, maybe there's market reasons to not recycle them. Maybe there's issues with kind of just still on the technological front of, like, getting it out and really kind of recycling it. So there's I think a lot of different issues that you have there. But I think a really big one, and it's sort of I think, like, if you're looking at it, I think through the lens of an environmentalist or maybe even an economist, it seems kind of paradoxical. Why would it be cheaper to do virgin mining than e-waste mining, right? Because, like, typically you say that within, like, a mobile phone, the concentration of e-waste is like that concentration of gold is like around 100-fold of what it would be in the ore, right? So it just doesn't logically make sense, but it's still, I think, one of those really big issues that you have.
Well, actually, I could probably point to an example. Right behind me is the Los Cedros Reserve. And that was where there was a gold and copper mining concession that was given. And it was a Canadian company, Cornerstone, that had been given the concessions from the Ecuadorian government to mine this area. And which was, became one of the precedent-setting rights of nature cases to protect Los Cedros. And my part in that, which, if someone had said to me a few years ago, I would have done, I would never have agreed. But we would do whatever we can do to save a forest. We wanted to prove that the value of this forest was worth more alive than mined. So the value of the mining concessions was X amount for the forest. But if we calculated just the carbon in the forest, not the biodiversity, because we still don't really have metrics to do that, but we have metrics to value the amount of carbon in this forest. And I was able to show that the forest was worth more in carbon than it was in the mining concessions. Yeah. Because ultimately, this incredibly biodiverse land is so cheap to use, to abuse, and to just explore. So that's what we see often, where the minerals are coming from are in countries where there's extreme poverty, and people will take whatever they get. And sadly, the devastation that's left behind is another matter, which is not equated for. And the companies that have mined it often are not held for cleaning up after themselves. So yeah, that's a kind of a direct example of how do we value the land as well, where these minerals are being extracted from.
Yeah, and I think that's a great example. There's actually, I think, another kind of quite nice statistic if we're looking at the other sort of end of the life cycle. It's from the UN Global E-Waste Monitor 2024. They estimated that there's actually 78 billion US dollars in externalized cost created through the pollution to both people and the environment through e-waste, and that was in 2022 alone, right? And most of that comes really from like the leakage that you get. Sort of lead and mercury emissions, plastic just kind of going all over the place, because I think that's also another thing that people don't think about, kind of all the plastic that there is in e-waste, but it's a major issue as well. And also just like the impact that it has on global warming, right? Because of course we have emissions through mining. Mining is quite an energy intensive, water intensive industry. So like all of that, right? And then still we kind of see that, there's sort of this market mismatch where it's like, oh, but it doesn't make, like, it economically doesn't make sense to deal with this issue, which, it seems really paradoxical.
And when I think about trying to recycle minerals, I mean, it must be a super complex process, which also will take so much energy. Let's not pretend that it doesn't. To how on earth do we? There's so many minerals in a phone. How do you even know how they extract? Is there a simple way of explaining how all those minerals can be extracted separately?
Well, I think there's a simple way of kind of explaining the most simple procedure for it, which is maybe not the most elegant one, right? And that's, I think, just kind of smashing and burning, right? So like the easiest way or the simplest way, and unfortunately also the way that happens quite often in the informal recycling sector, is to literally just take e-waste, whatever it then is, it can be your laptop, a computer, a phone, take a hammer or some sort of heavy object to it, smash it, right? And then you can try to like pick apart the pieces, like maybe you could already put the plastic, like the plastic that's on the outside to the side, and the rest you'll just kind of burn it down and then see, if you can pick it apart, right? Or maybe like if we're thinking about like wires, you just like remove the plastic coating and then you hope that you're left with the like the copper wiring in the inside or whatever material you have, right? So I think kind of the really simple raw way of breaking down e-waste is in essence quite straightforward or simple, but that's maybe not necessarily the way that you want to do it, right? Because I think it's maybe the elephant in the room, but if you start burning e-waste that has hazardous metals and it has plastic and it has all sorts of chemicals in it, like those fumes are not something that like you or any other species on this planet should be inhaling, right? And also if we're thinking about kind of what effects it has, then into the groundwater, if it rains down, or just if you're close to a river or lake, that's the next issue that you have. So that's kind of maybe the ugly, rough, old school way of recycling e-waste. But I think there's definitely kind of newer, more elegant ways of doing that, right? So I think we've seen a lot of innovation or like new processes being made around kind of just finding out different chemical solutions for taking apart e-waste, right? So normally it still starts with like disassembly. Maybe that's a better place to start. So if we're thinking about disassembly, we've seen a lot of innovation kind of on the robotics and automation front, right? Of just kind of, I think for an ordinary person, the best way to imagine it is that you almost have like a robotic hand or arm that can literally unscrew and maybe like take apart electronics that are broken. That's normally at this point a process that can't be done completely without people. It's normally sort of a little bit of like a coexistence, right? That you can maybe have a person place an electronic device at the right position, and then you can have a robotic arm unscrew it, and then maybe it will still be a person that will kind of take the pieces apart and sort them a little bit. So that's kind of maybe the innovation that we're seeing at the front, instead of the kind of just ordinary smashing that we've had in the past. And then I think once we kind of have maybe like our pieces of e-waste, or like maybe it's already been a little bit pre-sorted, then I think we've seen a lot of innovation happening over the last, I'd say specifically the last 2, 3, 4 years, around kind of using different chemical methods to separate the different elements in the e-waste. And I think what's been quite nice in that space is there's been a lot of innovations around kind of using chemicals that aren't as taxing for the environment as we've had in the past. A lot of innovation around finding kind of solutions that just aren't as energy intensive as water intensive as methods in the past, and maybe also just don't kind of replace that what we were talking about earlier about like the burning, right? So that's not happening in that uncontrolled way. So I think it's a space where we're seeing a lot of innovation. I think also for a lot of like specific different metals and minerals, right? And I think kind of as a whole, at least my feeling is that the sector is definitely moving in the right direction. But one of those key questions, and I think we already spoke about it earlier, is that a lot of people that I speak to in that sector still say, well, it's a big issue that if it's more expensive to do the recycling that way than the virgin mining, then we're back at that whole scenario that I described earlier on. But I think there again, like I said, the geopolitics can be quite interesting. That sometimes they might actually have a positive effect on local electronics recycling, just to kind of mitigate risks in the supply chain, as it's said so nicely in the industry, or in essence just make sure that they have the raw materials that they need. So that's kind of one big one. But I think also like as time progresses, some of those technologies are also getting cheaper, right? So that's also kind of another factor. And then I think also, like, maybe to talk a little bit about it, I think a smaller kind of trend or movement, but you see sometimes specifically kind of in the luxury or jewelry industry that there might be an interest to buy recycled gold or recycled silver that mostly probably has to do with kind of a marketing effect, or maybe just the fact that when people buy those products, they want to kind of do it with a cleaner conscience. So that's another, I think, trend that we're seeing in that space. Yeah.
And
so maybe that's kind of long answer, but those are kind of the different things that I think we're seeing in terms of how do you break it down.
Right. Well, I think that was a very good answer. Yes, we just smash it, basically. Humans are so
the terrible truth, right?
So smart. And I loved, I was at one of the design council events once, and a phrase that stood with me was that waste is a design flaw. Somebody
100% agree.
somewhere has designed that, and it has not been designed to be taken apart. It's not been in any way designed to be reclaimed. So surely this is the big movement that we really need to see at the beginning of all design, that the end of its life is just as important as the processing of it, of how are we going to disassemble this and how are we going to reclaim this, so that is embedded into the design process. So I don't know if you've got any wisdom for designers of how do we start with this? How do we really encourage them to include this design into whatever it is, especially with electronics?
Yeah. No, it's a great question. So maybe I might speak a little bit more to kind of the regulatory side again, because that's my background as an environmental lawyer. But I think, one of the big changes that we've been seeing on the market, it's, I think, been kind of slowly progressing that way over the last 10 years, has been the concept of right to repair, right? That an end consumer that buys an electronic device, or it doesn't even have to be an electronic device, could be anything else, but maybe because we're talking about e-waste and critical raw materials at the moment, that's what's relevant. So this concept that if you buy an electronic device as a consumer, it should be possible to repair it, right? And I think normally that entails a few different things, and I'll then also talk a little bit about maybe what designers can do in that context. So normally I think when we talk about the right to repair kind of as a more like as a policy or legal concept, it typically entails this idea that, well, first off, there needs to be some sort of guarantee or warranty on the device. So like if you buy it, it can't just break right away, but like if it breaks within a certain amount of time, that means that the producer, the manufacturer, needs to repair it for you for free, right? Or if they really can't do that, they have to give you a replacement. And in that scenario, you'd hope that whatever device then actually is waste also gets treated properly, right? Then normally there's sort of another phase as well, that's kind of incorporated in that concept, and that's sort of a time frame after kind of that original warranty or guarantee period, where you don't have the right to have a free repair anymore for the device, but you do have the right to demand that a repair is made, right? So if let's say the original guarantee or warranty phase was 2 years and your electronic device breaks after 2 years and 3 months, then maybe the manufacturer can say, okay, well, we're not repairing this for free anymore. But if you ask them to repair it, they can't just flat out say no, like we don't offer repairs or we're not helping you with repairs. They still have to kind of offer that service against a charge. So those are kind of, I think, like the first fundamental rights, which in essence already maybe kind of force designers to think a little bit differently, because, you know, you do at least need to be designing products that last long enough to kind of to meet those benchmarks. But then I think the part where it gets maybe more interesting for designers or more relevant is that you also talk about just in general, like that right to repair also entails kind of the right to get information about how to carry out a repair, right? So maybe repair instructions would be a part of that. It also entails the fact that a manufacturer needs to provide or produce spare parts and make them readily available for a somewhat fair price with a somewhat kind of fair sort of delivery time as well, right? Because nobody's going to wait 3 years to get a spare part for their broken laptop, right? So that's part of it as well. And then, you know, also this idea that kind of it needs to be easy for consumers to understand where they can carry out their repairs, right? So sometimes you have in these databases with repairers where you can bring your device. So those are kind of, I think, the core pillars of right to repair. We've, as a part of that, also started to see these kind of repairability indexes, which are really interesting, which kind of rank products in a similar way to kind of the energy efficiency classes that you have that go kind of from A down to F or G or H or even further down, to have something similar to that on electronic devices when you buy them as a consumer. That's something we've seen sort of develop in France and Belgium. And it really kind of goes on the packaging the same way as the energy label does. So I think that's kind of maybe the first framework that I would kind of put out, right? So I think we have kind of a concept or an idea for like, you know, how could we go about this? And I think then you're absolutely right, right? A lot of this kind of responsibility or thought process that we need to make sure that this actually works comes back to designers, right? And I think really, yeah, waste is really like it's a tragedy of design, right? Like to design electronic devices or any other device in a way that it sort of purposely breaks down after a certain amount of time because we think, okay, then we can sell our consumer a new one. It's kind of an insane thought, right? Like, yeah, I don't know, maybe people are going to disagree with me, but that's sort of how I see it. And I think it's really kind of, it's then also like just a question, you know, I think we talk quite often about how circularity or the circular economy or circular design or sustainable design, how they're these like new or innovative thoughts. And I always laugh because I'm like, no, because if we go back in time 100, 200 years, our economic models were largely circular, right? And if you look at nature, nature does not create waste. Nature is a perfect example of a circular system, right? So in essence, I think, you know, it's one of the things that I would always say to designers or just anybody in the space is we're not really creating something new here. We're trying to kind of relearn from nature. And we're also maybe just at a point where, you know, the innovation or the movement forward is actually very much inspired by something that we left behind, right? So I think that would be kind of general piece of wisdom. But I think it really kind of, I think, you know, if we're thinking about designers, like there's a lot of things that they can think about or that they probably should be thinking about when they're designing products, right? So I think it's things like how much energy, water, and raw materials do I need when I produce a product? How durable is this going to make this product, right? How can I make the product easier for a consumer or repairer to repair, where something like modular design can be really helpful. So just to like kind of build whatever it is in kind of chunks or blocks that can be swapped out when one is broken or just isn't really serving its purpose anymore. And I think, you know, then also kind of along with the modularity, like in terms of repairing it, it's also, I think, really interesting to think about how complex am I making this design, not just for repair purposes, but later for disassembly, right? If a device is much easier to open up, it's also going to be much easier to recycle later on. And I think something that we've seen a lot, especially in the electronics sector, it's just, you know, we have glue all over the place. We have an insane amount of screws and bolts. We also have bolts that are like made in a way that there's no tool to open them up, or you need a really specific tool, which in essence means you either need to smash it or drill it out. And we see plastic packaging that's just like on the outside and there's literally no way to get it open without it breaking. And then we also just see things that are welded shut, right? All of those things are, from my perspective, they're not necessary, right? We don't need designers putting that in there. So I think that's kind of the funny thing, that I think a lot of the solutions that are helpful for repair are also really helpful for the recycling. And I think one of the things that we really kind of also, that I always hear kind of in the market or in the industry from recyclers is, it's sort of insane how when you have sort of the manufacturing process, there's these like very clear guidelines of how is a product compiled and put together. In essence, you would need that at the other end of the life cycle as well, right? To disassemble it. You could disassemble things almost kind of in a sense in reverse from the way that you assembled them. But normally, those assembly instructions or manufacturing instructions, those aren't public knowledge, right? They're kind of behind closed scenes. So like then you have a device and you have no clue how to open it because you also don't have transparency on how it was originally assembled. And so every time, and that's also the problem with e-waste compared to kind of producing electronics, right? At the beginning of the life cycle, you're producing, I don't know, thousands or millions of the same laptop. At the end of the life cycle, when you're recycling laptops, you're going to have like hundreds or thousands of different models, and you don't have that information, right? So I think kind of information transparency there is also really, really important. And I think maybe still talking about kind of one nice tool, which I think influences designers, but is also kind of a policy tool or a tool that can help consumers, is this concept of digital product passports, right? That maybe we also just need some sort of tool or some sort of platform that actually helps to give transparency about kind of what goes into a product, but maybe also gives transparency around how it's been used, right? And that's one of the things that's sort of also a major aspect in battery passports, is not just, what are the individual components that went in, but it will also give you kind of information about the history of the product, which can also tell you then maybe things that you need to know when it comes to the repair or to the recycling later on. So I think I'm not sure if I fully answered your question. I think I talked a lot about kind of the broader frameworks, but I think there's a lot of space for designers to go into it. And I think one of the things that my colleague Saskia and I, we also wrote a newsletter about this, that I think what we need to see is just, we need a mind set shift within the design space, right? So I think we've been really focused on users, which is great, but maybe what we now need is to see kind of an equally big focus on the planet, and not just always think, what's the easiest or most convenient solution for the end user, but what's one that also kind of works with our planet and sort of the limited amount of raw materials that we have.
Well, that kind of segues nicely to the Design Council. For the next 3 years, the focus is #Design for Planet. And when they did the research, they found that only 42% of designers understood what that meant. Mm. So we can see that we've got over half the people designing our world that just don't know what design for planet means, which is why they, brought in people like myself to be these experts on the Design Council who come from different approaches. And what I was thinking as you were speaking then was like, oh, does this mean we're going to get rid of the inbuilt obsolescence department? The department whose job it is to make things break. I mean, when I learned that there was even such a thing, that these products are designed to last their warranty and then break. And naming Apple as one of, my pet, I had to get rid of my Apple products because of this. My fan went, I'd edited a lot of films on this MacBook Pro. I was working with these Americans, so I had to use Final Cut Pro. And then the fan started getting really noisy. So I thought, I just need to replace the fan. Oh, no, it's out of warranty, so you can't do that. Yeah. And so I went down this rabbit hole of trying to find a way to make the computer was fine. It was just noisy. Yeah. And then I discovered about the guy in America who used to teach people how to fix all their Apple gadgets, and they took him to court for teaching people how to fix them. And, and I just could not believe that they weren't behind that encouraging people to fix. But in fact, and what you're saying about this need for disassembly in the opposite to assembly makes absolute sense. It's like, yes, this is how it's made, this is how it's broken down. But my biggest viral post on LinkedIn, 40,000 impressions, was I wrote about a candle that my mum was given for Christmas.
Yeah.
And this candle had glass on the outside. It had some kind of jelly, some kind of toxic jelly in the middle, with a single-use electronic LED light attached to the candle inside the plastic holder. And when the candle was lit, it made the electronic LEDs light. And then once the candle had gone out, the whole thing was of no good. And on a very little sticker on the bottom, it said, do not put in your recycling or your rubbish. You must take this to your waste hold disposal set. Now, most people are not going to do that. They're just going to throw it in the bin, or they might throw it in thinking it's glass and we've got one hand, the fire brigade were doing a whole thing around Christmas of single-use electronics. Please don't throw them in the bins. This can cause fire. And then here we have two, it wasn't just one candle. One was from Lidl's and one was from Marks and Spencer's. And these two pretty similar idea candles. And I wrote this post saying, well, how can this be allowed to have a single-use electronic totally embedded within? You can't ever recycle this or separate any of these parts. And I ended up getting a letter from Marks and Spencer's offering to send a courier for the candle.
Yeah,
and I think we're slightly missing the point here, and but I really kind of like milked this because it got a lot of engagement. And making that point of like, this is a really good example of all that is wrong in design.
Yeah.
And whether we look at it from the danger of causing fires, or we look at it from an accessibility issue, that a lot of people are not able to get out to their tips, their dumps, to properly recycle it. So of course there were so many issues around this one product that really highlighted how badly designed so much of what we just buy. So yes, I think it was a good example. But so moving on from the inbuilt obsolescence department, what do we think that this new department should be called, replacing it?
I would say planet-centered design or something similar, right? I think we need to kind of just move. Yeah, we just need to shift the bar, right? And I think especially kind of in the electronic sector, it's a pretty long-standing issue, right? I think, you were talking about inbuilt obsolescence, and there was sort of like, I think one of the really early cases of kind of planned obsolescence that sort of was publicly exposed was the light bulb conspiracy, which was basically just a cartel of light bulb companies agreeing amongst themselves, how long the duration of a light bulb should be. And I think, recently we've seen kind of all of these issues around single-use vapes and just the crazy amounts of waste that's created in the battery fire. So I think, fundamentally, I think we need a complete shift. We need a department that's really focused on thinking, what can we do to create electronics or other products that just live a lot longer, that maybe just, that are kind of really designed in a way that they're focused on circularity. And I mean, really across all of the different phases. So, if I'm thinking about what materials am I putting in, like, can I maybe source those already in a recycled form, or can I source alternative materials that just aren't so taxing? I think, we talked about repair. That really needs to be kind of, I think, center and front. And I think it's also kind of, repair is also a matter of kind of speaking to your consumers, right? I think quite often we hear this sort of debate or idea that, well, maybe if we shift our attention too much on the planet or the environment, then that's taking away from user interest. And I really don't think that that's true, right? I think there's, the European Commission did research on this, and I can't remember the exact figures, but they asked consumers whether they wanted to be able to repair their electronics, and surprise, surprise, the vast majority said, yes, absolutely, we do, because why would you not want to be able to repair your device instead of having to go buy a new one? And
I think that I just wanted to do a call out for the repair cafes, which are really brilliant. And, a friend runs the local one here. And, it's just amazing how many things once a month it happens that get fixed on that day. And, these repairers, not just repairing it and somebody using it as a free fix-it shop, but actually teaching the people how to do it themselves. Why do most vacuums break? Because they haven't been cleaned out properly.
Yeah.
But the consumer isn't taught there is an inbuilt filter, not the external filter. There's another one. But if you don't know how to clear that out, you're just going to drive the motor out. And so that's education that's needed as well. So you have these places like these repair cafes. Yes, they're saving loads from going into landfill, but also educating people about how do we make things last longer. And that comes down to consumers as well. I mean, whether it's fashion and you do not need to wash your jeans every time you wear them, to how do we make electronics last longer? So all of this, and just before we finish, I just wanted to kind of bring it round to kind of law and how we can really get some important new laws around this. I mean, when we look at the single-use vape, how can that even be legal?
Yeah, I mean, it's a great question, right? I think this single-use vape, it really kind of existed in this gray space between a lots of regulations. I think that's why it's also been good now to see in the last maybe year or two, a lot of countries specifically ban them. But I think it really is kind of insane, right? That in this time of day, we still kind of are in a place where something like a single-use vape can even enter the market, right? And I think that really goes back to your question about like what do companies need to change? I think we just really need to get to a time and a place where waste is not an afterthought, right? I think we really need to have designers and manufacturers think about kind of the end of life when they're creating products. And I think we also maybe we always talk about end of life, but I think we really need to get to a place where that's not even the approach that we're taking, right? That we're thinking about kind of products having a secondary life and also thinking about what happens to products when they're really kind of not usable anymore. And I think that takes sort of different stages, right? So I think it's kind of one, how do we make sure that a device is repairable so it can be used as long as possible? How do we make sure that then, when it does break down, that it's easy to take apart, that you can kind of recuperate materials, that you can reuse them, and also fundamentally that you're not left with waste that just sits around and is harmful to the environment and to people, right? So I think we just really need to get to a point where we're designing for circularity, and we're also designing thinking about kind of the whole process. And it's not just like, okay, I'm focusing on the start, this is sort of like it's my focus is really just on what's happening until it breaks down, and then I don't care about what's after, right? But it's really like I think we just really need to move to a place where that whole life cycle is looked at, and there's responsibility taken really for all the life cycle stages of devices.
And that we can look back in the future and say there is no such thing as waste.
Exactly, right? I think waste sort of as a concept or as a term is already bizarre, right? I don't know why we have it, right? I think we should really kind of, I think it's a reframing thing. And I think language matters here to really start thinking about like secondary lives, secondary materials, and also maybe about third lives and kind of, that third tier of use of materials. It's sort of,
trash into treasure.
Trash into treasure, right? And then in a world or a universe where there's limited raw materials, like waste as a concept doesn't make sense. In a world where Mother Nature does not create waste, waste also doesn't make sense, right? Things should actually, in essence, infinitely be looping around. That's the only way that it works in the long run. And I think that's kind of just where we need to go as people, but also as businesses and as governments.
Absolutely. Thank you so much, Christine, for your work. And I'll put the links at the end of this so for people to carry on and look more, and do check out the e-waste column. It's something that we all really need to be a little bit more aware of. So thank you once again, and we'll stay in touch.
Yeah, thanks for having me, and thanks for the work that you're doing in the design space as well.
Yay. #design for planet.